The MediaPipe Audio Classifier task lets you classify audio clips into a set of defined categories, such as guitar music, a train whistle, or a bird song. To get started using the audio classifier, first take a look at the available audio classification model. You can see this list in the documentation linked in the description. The YAMNet model is an audio event classifier trained on the audio set dataset to predict audio events defined in the audio set data. Audio set is a large-scale dataset of manually annotated audio events. For information on the audio events recognized by this model, see the model labels list linked in the description. It's a good idea to try out the task in MediaPipe Studio to get a feel for the task and model before you dive into coding yourself. Once you're ready to add audio classification to your app, install the task's audio package. You can download the package using NPM and use a JavaScript compilation tool like Webpack, or you can import the package using a CDN. With the required package installed, we're ready to initialize the audio classifier. Here we have a function, createAudioClassifier. First, we configure our WASM binary loading using the FileSetResolver for audio tasks method. WebAssembly, or WASM, is a binary instruction format for a stack-based VM. You don't need to understand WASM to use MediaPipe solutions for the web. Just know that WASM allows non-web-based code to run on the web. Next, we create the audio classifier using the audio classifier createFromOptions method, passing in the FileSetResolver you just created and the model. Notice that the two assets are linked from external URLs. For the best user experience, you don't want to bundle your model or WASM binary into the website. Instead, store them server-side and provide links when initializing your audio classifier, as I've shown here. You can also provide optional parameters with your initialization. I've included them here so you can see their format. Display names locale sets the language of labels to use for display names provided in the metadata of the tasks model, if it's available. The default value is EN for English. You can add localized labels to the metadata of a custom model using the MediaPipe Metadata Writer API. Max results sets the optional maximum number of top-scored classification results to return. If the number is less than 0, all available results will be returned. Score threshold sets the prediction score threshold that overrides the one provided in the model metadata, if any. Results below this value are rejected. Category allow list sets the optional list of allowed category names. If it's not empty, classification results whose category name is not in this set will be filtered out. Duplicate or unknown category names are ignored. Category deny list sets the optional list of category names that are not allowed. If it's not empty, classification results whose category name is in this set will be filtered out. And again, duplicate or unknown category names are ignored. Note that this option is mutually exclusive with category allow list, and using both will result in an error. To run classification on audio, use the AudioClassifier.classify method, passing the audio data. This function is synchronous, which is good to keep in mind when designing your UI. Audio data is a float32 array of raw audio capture data, like that from a call to get channel data on an audio buffer. Sample rate is the sample rate in hertz of the provided audio data. If not set, the default value is 48,000. So, for example, you can create an audio buffer and then pass its channel data from the first channel and the sample rate to the classify method. This function returns an audio classification result object. There are a series of classifications in order of how confident the model is that the audio belongs to the given category. In this example, the audio at 100 milliseconds is most likely speech. The score of 0.6 is a score out of 1 for how likely the audio is to belong to the speech class. So that's 60%. The scores of all categories will add up to a total of 1, so we can stop there and assume that's what our audio is. You can access these classification results using classificationResult.classifications. Then you can iterate through the results to get the category name, score, and timestamp in milliseconds. To classify streaming audio, create an input buffer, get the channel data, and pass that buffer data to the audio classifier classify method. And that's it. With this code, you can get started with audio classification in your own web app. Check out a complete code example on CodePen and view all the available solutions on the MediaPipe website. Or get more hands-on with solutions in MediaPipe Studio. All these resources are linked in the description. As you can see, there are a lot of exciting places to go from here, so keep me in the loop. Tell me what you're working on, tell me what you learned, tell me what you still want to know. Drop a comment below here on YouTube or on LinkedIn. I can't wait to see what you build.